Like it's 2 o'clock here on the dot. We'll give everybody an extra minute or two to pop in. Okay, I think we've given everybody a couple extra minutes to pop in. I want to thank you for showing up today, especially at the day after a holiday here in the US when everybody's probably pretty busy trying to get things done. My name is Jason Ehrlich. I've been with Kinetics for about 20 years or so, and we're spent most of my time in the noise control. So this is what we're going to talk about here today. Appreciate you coming in. Got a varied audience as normal, so we tried to do a presentation that kind of cuts it down the middle from a technical standpoint. Appreciate again everybody coming in. Let's go ahead and get started. We're going to talk about spring isolated ceilings, and here you can see for concrete, and here you can see the 4 different varieties that we use for that purpose. With the exception of a specialty one that we're going to talk about, we try to price these all the same. We want you to use the right hanger, not necessarily the least expensive one. So let's start. We're not going to talk about too much about performance, but let's give a quick start on how this works for those of the listening in who may not know. If you look at adding mass, you can certainly add mass to help with noise control, but when you can split that mass up with something resilient and some airspace, you certainly get a lot better performance. And what we do is kind of cheat what's called the mass law, which states for every doubling of mass, a barrier is going to reduce sound 6 decibels. So if we take a 6-inch concrete slab, we take a look at a test report, we'll see that at 500 hertz, it's going to knock it down 52 decibels all by itself. If we double that then to 12, the mass law would say we'll get 58 dB at 500 hertz. Double it again, we can get 64 decibels of reduction at 50 hertz. If, however, we start with that same 6-inch slab, 52 decibels at 500 hertz, add something resilient and a couple layers of drywall for an overall 20-inch assembly, you look at the test reports and you'll see you get 84 decibels at 500 hertz. So not only are you getting 20 more dB, which is a giant reduction in noise, but you're also doing it at, for a very small percentage of the cost to build that assembly versus a 24-inch slab. First hanger we're going to look at is the original hanger. As far as I can tell, talking to all the historic folks in the industry, this was the first hanger that was kind of modified to do ceilings. It has one attachment point up here. You can go right to the deck or come down off a threaded rod. And this little spacer bracket kind of makes this product unique in that it holds this hanger rigid while you're installing that first layer of drywall. And then once the weight of that comes down, it pulls down and it is then in a state of deflection and therefore working. This 7 3/8 inch bracket we're going to see on a couple different configurations. Basically, when everything's all said and done with this bracket, with your deflection and your grid below, you're going to wind up with about a 12-inch airspace. And for those of you who aren't familiar with the typical grid, Here you see cold roll channel. This is available even in the local Home Depot or Lowe's. Perpendicular to that, we would run what's called drywall furring channel. This one happens to be 7/8 of an inch thick. Here's your cold roll back there. Again, we install this perpendicularly every 12 or 16 inches or so. And typical for a ceiling like this, you'll see 2 layers of drywall. When we put it all together, you see here's our slab, here's the ICC hanger, here's your cold roll channel running towards you, and here's the furring channel running the other direction, and your 2 layers of drywall. And you'll typically see up to 4 inches of loose batt fiberglass in the airspace cavity. The next hanger takes that same exact bracket, same coils, adds a rubber element at the top, and then 2 welded eye bolts for wire tie purposes. It's important to note that you do want to use a welded eye bolt. I would get it from Kinetics. Otherwise, it's not going to reach the overload capacity needed for code. All of these hangers have a 5-time safety factor built into them. The one thing to be cautious of when using this particular hanger, which is a contractor favorite, is they're probably going to try to substitute in the ceiling grid made by Armstrong and other third parties. What you have to watch out for is you don't want any hard attachments at the perimeter, and that's the first step of those systems. We can give you a detail with a resilient element in there, but you do have to kind of watch that job site to make sure they've got it at the right place, because once they anchor that in, obviously it's not going to move. And it's a little bit more difficult to change things in the field, because if they get that wrong, you're going to get pressure against that side grid. So yes, the contractors do prefer it because it goes up a little quicker, but there are some things that you need to keep your eye on when you're on the job site. Next, we have the Gotham hanger. This was specifically designed, started out anyway, for our reps in New York City, where you can't use wire tie, but they wanted that rubber element and some of the other configurations. You can't install this directly to the deck because you basically will short out this element right here. Once this touches the deck, this really doesn't serve any purpose. So you have to keep it down from the deck. There is a modest cost increase on this particular hanger. It's a little bit trickier for us to assemble here in the factory. Lastly, we have the KSCH hanger. And for those of you who are more familiar with us, you may recognize this. It's been out for quite a few years, but we did modify it a 3 years ago to do a full 1-inch deflection hanger, because that was demanded. The other thing we saw, kind of responding to what we were seeing in the field, was we added a threaded insert here. And the reason we did that is you're seeing things now where you'll be in a mechanical room and they want to do the isolated ceiling, they want to do duct, they want to do pipe, they want to do lighting grid, they want to do all kinds of things. And we wanted to do something that allowed for some more flexibility. And what that can let you do is, one thing is add this piece right here, which we call an APB, and it basically lets you move that channel down here to get better performance. It's literally called APB, which stands for Airspace Performance Bracket. And we recognize the fact that our full 12-inch of airspace was sometimes not practical in some applications, but there's a big difference in performance from the 3.5 inches of airspace this configuration would allow, and then basically any adjustment on this configuration. And again, the other thing you can do is just drop straight threaded rod through there, down through your drywall ceiling, and then set up other grids to do your pipe, your duct, and other pieces of the kitchen sink ceilings, as we like to call them here. And here you see one options that we have available is this different bracket. There's different widths. The standard piece will slide right into unistrut, where the other piece is a little bit wider that lets for diagonal powder shooting. You can powder shoot right into the deck. So it's a pretty versatile hanger, and you can kind of see on this particular detail where you can combine it, where you've got, say, duct in the corner, or in this case, a piece of concrete that comes down. You can combine this hanger with this hanger for challenging type installations particularly along the perimeter of the room. We see that all the time. Moving on, let's take a look at a sound test with this hanger. It's kind of neat. These were all done up at NRC in Canada, outside of Ottawa, a few years ago. But it's a fair test because we did these all in series. So here you see in that standard installation with a 3 and about 3/8 inch airspace, 2 layers of drywall. This particular assembly tested out at an STC 69 IIC 54. On this one, we added just a thin little underlayment and some tile to it. And as you might expect, the STC stayed the same. We didn't add much mass to it, but the IIC, those impact numbers, did go up because of that rubber right at the impact of your feet, take some of that damping ringing out of the concrete. Then we tore the ceiling down and put the airspace performance bracket in and tested an 8-inch airspace. And here you see we got an STC 80 and an IIC of 64. So, you know, that airspace definitely led to the performance jump of the STC, and we got a couple points on IIC. We ripped the ceiling down once again and then went with a full 12-inch airspace in this configuration. And you can see we got an STC of 81 and an IIC of 60. And I really like to point this particular series of tests out to architects and other maybe non-acoustical experts when they call in, because it does kind of illustrate a phenomenon you see sometimes in noise control. With this particular lab setup, the way it worked out, we actually got a better IIC performance of 64 with a smaller airspace than a 12-inch airspace, which is counterintuitive. I think most people would assume you'll do a little bit better with more airspace up until a point. Look, it held true for that particular assembly, and that's the difference between talking to kinetics. We'll feel free to give you kind of a good, better, best, but then we're going to tell you to call a consultant to see how well it's going to go into your particular construction. And this is a perfect way to kind of look at that, because you know, the general rule of thumb is more airspace is good, up to about 12 inches or so from what I've heard. But here you can see it ran counter to that. Let's take a look at our website. If you haven't been there lately, we've redone all of our noise control building materials product pages. And there's a lot of things at your disposal. We want to kind of share those with you so you can see what is available. So here is the screen, and if we look at this thing, let's start from a specification standpoint. Like we are the acoustical consultants that might be listed in, they're probably going to head here to the testing results. Well, here are all the tests. You can download them, see what you want. If we had any fire tests or anything like that, they would be down here below. So typically, I think this is where most consultants are going to at least start the journey. They then specify the product and they tell the architect, hey, this is the product to use, and which we think the drawings in BIM was where the architect will probably start their journey. And here you see the BIM object at the top, and there's different drawings. We give you both the PDF and the CAD when we think that the CAD may be useful for getting things into project drawings. That's kind of the separation between the drawings you'll find on this tab and the drawings that you'll find on the submittal docs. Another feature we have on here that's kind of neat is this 3D kind of model that you can go in there and take a look at different configurations. It takes a second to load up here. And then once you're in here, you can take your mouse and kind of freeform, move things around, check out a certain detail if you want, or you can go ahead and just take a tour starting at number 1, and there's little pieces of information for you, and you can go through, and here we're talking about the perimeter tape, and you can even click on the link to get to the specification sheet on that. And it just kind of highlights a view. This is kind of a universal thing, I think, both for the architect to try to detail things out, as well as the installing contractor, that if they have a question on how something is done, because everything in this model is built to scale. So kind of a neat little fun tool. You can do full screen, and my understanding is you can even put on your VR goggles and enjoy it. And then scrolling down again, anything that we think is useful to the designer is going to have a CAD drawing. and different products will vary by how many different things are available. On the submittal docs page, we wanted to start out like, what is a submittal doc? Well, we have, data sheets, specs, lead, SDS, and you can click on them, get a preview, download them one by one, or you can click these orange boxes and kind of build yourself up a spec packet. Over here, click export, it puts it all in one compressed folder. We do have everything in here. If you want the tests, you can come here, click this, download the tests. You want system components, these are kind of accessory items. Again, the drawings, you'll have more drawings here that aren't included on the other page because these aren't necessarily needed for project documents. It's just kind of general information, but all kinds of drawings and other kind of documents. Installation, we wanted to make things as comfortable for the contractors that we can. And so what we try to do is have a CAD drawing, a rendering, and a photo if we have a good one. On this particular example, we don't, a relatively new hanger on the market. But we wanted to take a lot of the fear out of the contractor so they don't try to just out of that fear get a ridiculous install price. And what this is just basically a step-by-step, not necessarily installation instructions, but just a step-by-step guide to how to install a typical ceiling. Lastly, you're going to see different things on the design guidelines depending on the product. This particular one, we really wanted to try and get people to this construction documents guide. And if you click on this, it's basically, when we're trying to turn shop drawings around for a project, many times we just don't have the right details that we need, and a lot of time is lost saying, how do we do this? How do we do that? What this particular document is trying to do is say, hey, to turn this around so everybody understands everybody, if you can have these kind of things included in your drawing packet for us, it's just going to make it that much easier for us or even another vendor to help put your shop drawings together. But you'll find other things on this document depending on what the product is and what you're trying to do with it. Here's a selection guideline if you want to try to install it yourself without any shop drawings. So I'll leave this screen up while I answer some questions. Thank you again for listening in. Looks like we have quite a few questions here. Let me start with Matthew is writing, do you have a detail of that perimeter condition that can be shared? I do. In fact, I might be able to just go back to our handy website here. And go to drawings. And here you see the various different details. I think you might be referring to the one with the third-party grid. Let me see. We should even have that. I am going to click very quickly and go to our Muta page. Go to the drawings. Oh, well, it is here. It's pretty generic though, admittedly, but if you take a look at that drawing up close, you'll see that is the ceiling grid. We really want to talk to you about what that fastener detail looks like, because you do want to keep the fastener itself isolated. Oh, Louis Sunga, how are you? You asked, you mentioned that there are hangers are comparably priced. What is the conservative cost that we can quote to clients / contractors? And yes, I'll send you out a version of the presentation. Whenever I get asked about cost, I always go back to say, especially with ceiling hangers, the shape of that ceiling has so much to do with the cost. If you have a giant rectangle, you are going to get roughly 12, 13, maybe even 14 square feet per hanger when it's all said and done. But if you have a ceiling layout that has all kinds of crooks and corners and they want to do the closets on the project, the lowest I've ever seen is 9 square feet per hanger. Obviously, there's going to be a giant difference in how much that overall project costs based on the shape of that ceiling. I can tell you that generally speaking, after it's delivered to the job site and everybody's done all their markups, we see these things, conservatively somewhere between $25 and $30 a piece. But again, the size of the project and the shape of that ceiling has so much more to do with what the final costs are going to be. Jonathan asked, very curious as to why the IIC would go down from 8-inch to 12-inch airspace. Any theories? Well, I'm sure some folks that are listening in would have some opinion. My thoughts are that you've probably got some specific waves, probably near that middle to higher frequencies where IIC is rated, are causing some resonance in that 12-inch cavity that we're not getting in the 8-inch cavity. But that is just my guess. But if somebody wants to chime in with their theories, I'll pass them along as we're listening in here. Craig asks, are there to be installed post or current? Are these to be installed post or current construction? They certainly, either one. We see more and more where they find out they've got a noise control problem and they put these in after the fact. It does happen a lot. So I'll go back to you guys can see that information. So it really does kind of depend. We get tons of calls where they don't put something in until afterwards and there's a problem and they got to move people out and put these in. Obviously the big challenge with these things, especially on those quote unquote kitchen sinks where you've got ducts and pipes and everything else, is that coordination aspect. There is some flexibility in our layout, but generally what happens is that ceiling grid itself is the constraint on how much weight it can take, and we got to sometimes tighten up the ceiling hangers just so we don't overload the grid. Hope that answers your question. All right, anybody else? Again, I want to thank everybody, especially trying to catch up after a holiday weekend.